My name is Jeremiah Hansen. I'm on our field CTO team at Snowflake. I've been at Snowflake 4 years now. Background prior to Snowflake was pretty much on the delivery side. So I worked for Slalom Consulting for 9 years, where I led their cloud data engineering DevOps practice. And then prior to that, I had various roles as a developer and data engineer. So at Snowflake, I focus on data engineering in particular for the field CTO office. I'm looking forward to chatting with you today about data engineering in Snowpark. So if you've seen a lot of the content out with Snowpark over the last year or so, it's been pretty much mostly focused around data science. And what we're going to go through today is content around looking at that from a data engineering perspective. So applying some data engineering best practices. There's overlap, of course, but they're different. So today what we're going to do is go through, I'm just going to talk a little bit about data engineering, some of the phases and some misconceptions around data engineering, I think, and then do a brief overview of Snowpark Python and kind of how it works and some of the things you need to keep in mind. And then I'll talk about the Quickstart or demo, and I'll explain all that. And we'll spend about the last 15, 20 minutes or so actually going through and show you parts of the demo and some of the key things. So excited to go through this with y'all. So a couple quick questions though for the room before I get into this. How many folks would consider themselves sort of a traditional SQL-based developer, data engineer? Okay, it feels like over half, feels like maybe the majority. What about Python data engineer? Whoa, lots, okay. And for the folks that raise their hands for Python, predominantly like DataFrame style engineering, yeah? Yeah, maybe do hands real quick, yeah? I think it's, okay, it looks like most of the same folks. Okay, good, so we'll go through and show you a couple of the options here today as we get into it. So I'm gonna go through a lot, and I'll share some links as well to this quick start where you can actually go through after you leave and see a lot of this written down. So if it doesn't, you don't get it all in, you can go back and review it. But data engineering really is a broad discipline. Like I always view data engineering as the base for everything else. Like for whatever you're doing, you have to ingest the data, transform it, get it ready. Sometimes I see people talking about data engineering today as in the context strictly of data science, that it's somehow a data science specific thing, and it's not. It's much broader than that. Now, certainly you do have to transform data for data science work, but broad. So that's what we're going to cover today. I think it's really helpful I like to make things simple and then drill down. So I think at the high level, I think it's really important to break data engineering into ingestion, transformation, and consumption. At each phase, there's different tools, there's different approaches that you're going to take to work with data. We're going to focus primarily today on transformation. I'll talk a little bit about ingesting and some schema evolution stuff, but primarily data transformation work today. But the idea with ingestion is you're going to get a one-to-one copy of your source into a raw zone. You're going to transform it in various ways, and then it's going to be ready for consumption. So pretty straightforward, right? But some of the misunderstandings that I see sometimes are around this idea that somehow raw data has to be files and you have to use Spark to do that. And we're going to show you today that you don't have to use Spark and you don't have to have raw files. You can actually use a data platform like Snowflake to manage the data and then Python to transform it. So I think the simplest way to describe it, like I was saying, is raw and transformed. The other really popular way today that they go talk about data engineering is with this medallion architecture. You probably have seen this, right? Bronze, silver, gold, or heard that. That's like for file-based data lake folks, that's sort of the common way to do it today. But it's the same thing. I just want to point out, like, it doesn't matter what you name it. The point is you have raw data that you're transforming. And picking the names, I don't love the names bronze, silver, gold, they're fine. The worst I saw once was I was as a consultant with a client, and they like the kitchen theme. So they had raw for their raw data, and then they had cooked for their like transform data. And it was financial data, which is like, just seems so wrong to like have cooked financial data. So you gotta be a little careful, but ultimately you gotta pick something that's meaningful. But the point here really is, like if you look at your zones, this is from a presentation I did last year, but if you have a raw and transform zones, and there's other things you might have, right? Like a work area or sandbox and the conformed and reference. But I think just so ingrained in so many folks' minds today when it comes to data engineering is, boy, raw data has to be in a data lake and has to have Spark to transform it. And that's just because that's the way it's been for the last 10 years. And for file-based, data lake customers, that's what they had to deal with. But this idea of data lake and data marts and data warehouse, I wish we'd kind of stop using these terms because They are legacy. They just bring to mind legacy siloed approaches to managing data. We're really in Snowflake, which we'll show you as we go through, but all that data can be in Snowflake. It can be governed consistently at like a low level, row, column level, can be transformed through, show you how to do it with Snowpark, which is faster than Spark. So you'll see all the benefits of this, but the idea is we have to stop thinking about data lake and raw data as files and model data as, in a data warehouse. That's for these legacy solutions that can't support all those workloads. So, and I talk to customers about this a lot. AMN Health is one of our kind of case studies of a customer who went down the kind of this path of file-based data lake, Spark for the raw data, and then transformed and put it into some data warehouse. And they found that it was just super slow and hard to deal with. And this is all in Azure. They built it like with just the data lake and Spark. And then they went to Databricks and found not much improvement. Then they went to Snowflake and put all those zones of data into Snowflake, did all their data engineering in Snowflake, and found for them in this case was 93% cost savings, primarily due to less complexity and fewer people to maintain the system, which is what customers find over and over again. So with that, just quickly want to talk about Snowpark. How many people have kind of understand Snowpark and in any flavor, Python or Scala or Java? Yeah, maybe not quite half, close to half. So I'm going to spend a few minutes though explaining. I think there's some important concepts that you're going to want to understand as we get into this. First of all, Snowflake, there's so many ways to do data engineering. So today we're obviously focusing specifically on Python and doing it with Snowpark, but there's so many tools and languages and ways to do it that, I won't go through all of it here. This is showing the Snowflake specific features for ingesting and transforming and then orchestrating data. What we're really going to focus on today is Snowpark for transformation. We'll talk a little bit about schema detection as well. But that's where we're going to spend our time today. So lots of features. It was announced today that public preview, we're now in public preview for dynamic tables, which are awesome. And I'm not going to cover that today, but lots of ways to do transformations in Snowflake. So, okay, when it comes to Snowpark, it's a kind of an umbrella term. That's the first thing to know. It incorporates a bunch of features or a number of features from Snowflake. On the server side, we'll start at the bottom here. The server side, from the beginning, Snowflake has supported SQL and really JavaScript as a way to script and do some programmatic work. What Snowpark added was this ability to run Python, Java, and Scala natively in Snowflake. So that's the first piece you got to understand. This code, the Python code in our case, runs natively inside of a Snowflake warehouse. The top side, the client side piece, we have I asked earlier about folks that did Python data engineering if they did it in a DataFrame style or DataFrame API. That's what the client side piece is. It's primarily a DataFrame API. We'll show that in the demo here, but for those who aren't familiar with DataFrames, it's a programmatic way to build a query. It's actually very similar to a SQL query, just expressed differently, but conceptually the same exact thing. You're joining tables, filtering tables, doing all that work like you do in a SQL query. So, but what Snowpark allows is to have that same API. So if you have built stuff in PySpark, that API is very similar to our Snowpark API. And so that code can be migrated very easily. There are some differences between those, but they're pretty similar. So easy to migrate code. So anybody that is familiar with PySpark and that client-side piece is what you're familiar with. So two pieces, and I'll show you in a second kind of how they relate together. But the big reason we did Snowpark, some of this was talked about today a little bit, governance. So maybe start in the middle there, but if you've worked in Spark-based solutions, governance is a challenge, and doing it consistently at like a row and column level, regardless of language or tool, it can be a challenge. So that was one thing we wanted to have make sure of, was that when we run Python, it's in a secure sandbox and that security is not violated. Like with Snowflake, with Snowpark, it doesn't matter how you access the data, with what language or tool, the data is always secure. So that's that really important part. The second one was about just languages. Like I said, there's so many ways to do data engineering. So letting folks work with whatever language they want, really important. So that was the second part. And then making it simple. So Snowflake, managing Spark clusters and optimizing and doing all that's a lot of work. Snowflake, they run on our standard warehouses, and it's easy to let Snowflake take care of all that for you. So I mentioned this actually, Python's actually running inside of the warehouse. The same warehouse you've been using with Snowflake, you can leverage it to run Python. So you get all those benefits. You get the instant startup time. For most size warehouses, it's sub-second to start up a warehouse or resize it. But being able to just everything we built in, the security, access control, all of that, you take advantage of what you're familiar with Snowflake. So Snowflake is primarily, first and foremost, an enterprise database platform, data management platform. This is different than Spark. Spark is a query service for files. It's not a database. So you got to think, so as we think about how to translate maybe a Spark notebook to what we have in Snowflake, these concepts are going to be important. So everything in Snowflake has to be captured or represented with a database object. So we've got UDFs, which you should be familiar with. A UDF, user-defined function, returns a scalar value, and it's really meant to operate on a row of data. So you've got a row of data, you pass some attributes, and you get a scalar value back. Vectorized UDF is about just doing that in parallel. So it's the same idea, but just in parallel. A UDTF is a user-defined table function. That's about actually returning a table of data. Okay, and then stored procedures is really in Snowflake how you're going to store procedural code. So like a script. So really the way to think about a stored procedure is kind of like a notebook. Python notebook is a series of Python commands that run. That would be translated closest into like a stored procedure. And so I'll show you that. We'll build our pipelines with stored procedures here. And then depending, notebooks are usually a combination of things. Like they're usually actually creating UDFs and doing the code. Like it's a bunch of stuff, which isn't best practice way to manage objects, in my opinion, in a lot of ways. So you might actually pull out pieces and create UDFs as well. So you might take a notebook and split it into a couple UDFs and a stored procedure, for example. So hopefully that helps us start to think about how to maybe translate from one to the other. But those are the core objects in Snowflake. And then the client API we talked about, not an object that lives like as a Snowflake object, but the client library that gives you the DataFrame API. This just kind of shows essentially the way these two things might work together. So we have objects and we've got the DataFrame API. So like I mentioned, DataFrame is really just a way to run a query, in this kind of programmatic object-oriented way. So imagine you've got this filter clause, which is like a where clause. What will happen is the Snowpark client API actually converts that into a SQL query. So every DataFrame expression in the Snowpark API gets translated to a SQL query, which is actually, as a side note, why Snowflake is so fast at running these Python DataFrame expressions, because it runs in our query engine. And that's why, compared to running it in Spark, why we run so much faster. We have a really fast vectorized query engine that we've had from the beginning that supports, the true like BI kind of real-time workload, like interactive query workloads. And that's ultimately what happens is all those queries get translated and run in SQL. Then any object you have like a UDF or a stored procedure, it actually gets stored and run inside of that Python environment that we talked about. And then have you seen the movie Inception with Leonardo DiCaprio? I love that movie. It's like every time you watch it, you got to spend a bunch of time thinking about it. But this kind of happens here. It's like a little bit of an Inception thing. You got to think about always where the code is running, like where the Python code is running, because that Python code running inside of Snowflake can have a DataFrame expression that can then generate a SQL query and run a SQL query. And that's why you see that line kind of going to the side. So when you run that Python code on your laptop, the code's running on our laptop, but the DataFrame expressions, those SQL queries run against Snowflake. When you run it in Snowflake, that code runs in Snowflake and then creates SQL queries. And all this is in the query history, so you can actually see this and you can debug kind of what's happening, which is really cool. All right, hopefully that makes sense. That kind of gives you the overview of what we're talking about with Snowpark. So I'm going to move on now to talk about the Quickstart itself. So if you haven't seen already, quickstarts.snowflake.com, you should definitely, it's easy to remember, but this is a great website and it has a ton of quick starts, which are step-by-step guides on a various topic. And this covers partner tools. It also covers features in Snowflake. So the one that I have created is called Data Engineering Pipelines with Snowpark Python. And what I'm going to do when I get into the demo part here is show you parts of this quick start. But this is all available for you. So as soon as you get home from Summit, you can get, or even tonight if you wanted, if you're excited, you could get on this and start going through this step-by-step guide. So we do have like 3 hands-on labs at Summit, but I think they're all already booked out for this. So you can go through it yourself as well. There's I can share other resources as well around it. But really the thing to point out, I'm just going to quickly explain what this does. There's a lot in this. But for folks wanting to do data engineering, I think you have kind of all the different building blocks you would need and the different pieces you would need. So we start by, setting up the database and the objects. And then, I don't know if you all heard of Tasty Bytes. So our new demo framework or demo data set is called Tasty Bytes. We used to have City Bike, if you remember seeing like City Bike demos. Now we have Tasty Bytes, which is a food truck company, but nothing different. It reminds me of like AdventureWorks. Did y'all like work with AdventureWorks back in the day? That was like always the standard data set. So what we're going to do in that stage 2 is that data. So we're going to ingest from Parquet using schema inference. We're going to ingest all those tables, the point of sale tables. We're going to then I'm going to talk about data sharing. This actually was mentioned a couple times in the keynote, but in my opinion, the best data pipeline is the one you don't have to build. And we'll talk about building data pipelines, but what if you have to even do that to begin with? What if you could just get a share from somebody and start using it? That's even better. So we'll take some weather data and we'll use that later on. But we're going to create a view that flattens these tables out and then a stream on the view, which is cool. So streams in Snowflake is our change data capture mechanism that let you process data incrementally. And you can actually now create a stream on a view that joins tables. So that's pretty cool. There's limitations on what you can do. It has to be like just inner joins at this point, but pretty neat. So starting it, and then we'll have a UDF in Python and SQL, where we'll do, in one case, we're just going to do some simple weather conversion with that. And then our actual pipelines, if you want to think about kind of the unit of a pipeline, we're going to have it be a stored procedure. So on step 6 there, where we're going to create an orders table. And we're going to basically do like a merge operation to create the orders table. We're going to also create a aggregated table that joins together orders and weather data. And then we're going to use tasks to orchestrate it. So tasks in Snowflake is the orchestration component. I'll show some of the new visualization capabilities we have in the Snowflake UI for this. And then run it incrementally. And then I've even got in the Quickstarts, I love DevOps, I've even got a example with GitHub Actions of how to deploy these Snowpark objects through an automated pipeline. So this should have everything you need to get started. And what I'll do is we'll spend some time just going through and talking about some of the key parts and the tools and things that you're going to need to use. So throughout the quick start or the demo, there's a lot of benefits for using Snowflake for doing data engineering. And this is the list. I won't run through all of them. I've talked about some of them. We'll talk about VSCode and Snow CLI. Those were both announced this morning as part of the keynote. But the rest of the things I've kind of touched on as we went through the last diagram. Okay, and we talked about Tasty Bytes already. Okay, so now the moment of truth. I have to go back over to here. Okay, first of all, VS Code. Who uses VS Code as their editor? Yeah, good. Love VS Code. I mean, there's obviously lots of IDEs out there. There's already been requests for other IDEs now for Snowflake to support other ones, and I'm sure we'll get to it. But VS Code is the most popular open source IDE. I'm showing it here. I've got the first thing I want to point out is the Snowflake extension. So on the left in your extensions, you see the Snowflake. This is a native Snowflake extension. There's been some third-party ones in the past that were okay, but now we have a native one, and it's a native VS Code extension as well. So you get, like with any IDE, you get, you log in, so it saves your accounts you've used before. You can select your default role and warehouse and all the things you'd expect. All these tools are very similar. So you can log in. You're able to explore the database here as well. So, just like you'd expect, we have this hands-on lab database. We've got a stage here defined. One of the cool things that you can do now, even in the Snow site UI, is like explore the files in your stage. So you can go in and browse the folder structure. You can even upload and download files to your stage right from here. So really cool. Like you just get a really nice integration. And then you have also a query history here as well. And it's just like our kind of other experiences where you can click back and see previous results and all that business. So really, really awesome. I mean, the fact that VS Code has such great Git integration natively, it's really easy now to have your scripts checked into source control, run them, debug them right in here. You don't have to really ever go into the Snowflake UI, or at least less often for doing your development work. And then you're in VS Code, so if you're doing Python work or others, like it's all here. So awesome. A key part of going through all this. That's the first part. So once you go through the quick start, all these files and scripts and everything is in a repo that you'll get access to. There's a link from the quick start to get to it. So that's the first part. You can run, this thing has a series of, you'll see the extensions, we have a series of SQL and Python scripts. So you can mix and match the SQL script 0.1 just sets everything up. I want to go through and talk about a couple features at each step. So if you remember back, step 2 was we're going to load Parquet data into tables in Snowflake. So we've got the data in Python. We're going to load data. And so this is I mentioned that the client API is primarily DataFrame API, and that is true, but there's also other methods and classes in there as well, libraries in there. So one of them, if you go down here, you can see really in this section, we're basically going through and we have a number of tables we're going to load. So the session object, just like PySpark, I mentioned the API is basically the same. So we got the session object. We're going to read files from a stage. So we've got Parquet files in a stage. As you're probably aware, right? Everything in Snowflake, all file access is through a stage. So we're reading that as Parquet files. And then this copy into table function that's available, or method, this is actually using schema inference. So it's actually going out, reading the Parquet files, inferring the schema, and it's actually creating tables with the structure. So they'll have columns from the Parquet file. So schema detection network. So pretty cool, that's all built in. We announced today that schema detection was public preview for all formats. It's weird, they're kind of at different stages. So like CSV files are different, text files were the hardest. So JSON and CSV were the hardest, but they're all now public preview and then schema evolution as well. So that's all built in there, which is awesome. I'm gonna show you a couple little tricks. So you can still do the .SQL method like you would before. So I asked earlier about, who's using data frame expressions, because a lot of times I talk to a lot of customers who are using PySpark, but just writing SQL queries. And you can definitely do that as well here. So you can see what we're doing. We're at the beginning and end of this function, we're changing the warehouse size. So one of the awesome things about Snowflake, right? The warehouses can be created and resized instantly. So we're resizing it. So we start out, we resize to an extra large, it happens sub-second. We can load data, because Snowflake bills per second with a 60-second minimum. If you run the same job and with 8 times the resources in an 1/8 of the time, you pay the same amount. So why not run things quicker? So it's an incredible Snowflake, benefit. So we're resizing, running our loads, and then sizing back down. So I have this in a number of the scripts as a pattern. It's just awesome. And it's one of those things about Snowflake that when you start doing anything with Snowflake, but particularly data engineering, you got to think differently about how you do it. So that's a couple of things to point out there. On the weather front, so I talked about the best way, I think the best data pipeline is one you don't have to build. And that's what data sharing allows you to do. So here we've got the marketplace. In this particular demo, there's a data set available here called Frostbite, which is that new demo we mentioned to you. And you got this from WeatherSource. So WeatherSource is a partner of ours, and they've created a data set just for us to use for the demo. We've used Marketplace so far to get access to data sets, maybe a third or so. The nice thing is, to get access, there's a little blue get button. I already did it before to run through all the steps. But as soon as you do that, then it shows up as a database. And in this case, it's the Frostbite Tasty Bites. Oh no, it's not this one. It's called Frostbite WeatherSource. And it just immediately shows up as a database in your account, and you can grant permissions to it like you'd expect. And then you got a series of views now that come from them. So immediately the data is available. You can join it to your data. There's no performance impact whatsoever, and it's available for you to use. So that's definitely the preferred way to do it. So now I want to talk a little bit about kind of some of these pieces. First thing I got to talk about is the Snow CLI tool. So it was mentioned today that it's actually in private preview. The Snow CLI tool, it's a little confusing because we have Snow CLI and we have Snow SQL. They kind of sound similar. Snow SQL we've had for a long time. It's the interactive, query command line tool. Snow CLI is going to be more for developers. It's a command line tool to help with various tasks and activities. Eventually, these are going to merge. So eventually, we're going to have one tool, which is going to be the Snow CLI tool. But for now, they're two. So you've got to keep them separate. The Snow CLI tool, you type the key, the tool name is Snow. And for Snow SQL, it's Snow SQL. So keep that straight for now. But this demo uses the Snow CLI tool extensively. One of the key things I think when you're doing data engineering with Snowpark is in my opinion, you want the development experience and what the code that you create and you test to be the same code that you deploy to test, into QA, into prod. I think that's important, right? You want to use the same tools. Like ideally, those pieces aren't changing, so it's, you're just deploying it to each environment. A lot of the stuff you'll see online for people have put a lot of examples forward of how to do data engineering or how to manage your objects with Snowpark. I don't like a lot of them because a lot of them involve the code changing in some way. Like they'll take the code and they'll wrap it later with other stuff or serialize it or do different things. So I think you want to have it be as close to the same thing exactly. And that's what this does. So there's a little bit of, I don't want to get too far into the weeds, but there's some boilerplates at the bottom that help for debugging locally. So you can run this locally. So I can write from so this is a UDF. First of all, I probably didn't explain that. It's just taking a temperature, and it's right now it's hard coded to returning the temperature in Celsius. So it takes a Fahrenheit, returns Celsius. So it's pretty simple. If I pull up the terminal, I can run it directly from the command line. So I'll have to pass a temperature. And you can see it returns 10. So really simple. But the point is I can debug this locally. And since this doesn't connect to Snowflake, remember the inception thing where I said, like, if you have a DataFrame query, that runs a query? Well, this doesn't do anything with data frames, or it just runs locally. There's nothing touched Snowflake for this example so far. So now I've got my UDF ready. And as we go through the demo and the quick start, I come back to this and we actually update it and import a package and do this with a library instead of hard-coded. So you can see that example, but this is super simple. So the snow command is the keyword snow. And in this case, it's a function that I want to create. So snow function create. And because my user account has MFA turned on, I have to just accept it here. But what this does, this is really powerful. And in the quick start, I actually explain all the steps this goes through. But ultimately, this code, like I mentioned, has to be stored in Snowflake in an object. And so what this does is it actually generates a create procedure body. It takes all the code and zips it up. So you can have other Python, packages in here. It will zip it up, and it will actually upload it to a stage and do all the work that you need to do to set things up. So it's really helpful. And I can show you actually out in the. So I mentioned everything happens. One thing I love about Snowflake, when I first got introduced to Snowflake, whatever it was 4 or 5 years ago, I love the query history. Coming from previous database systems, like it was just such a pain. This is so easy to see everything that runs all the time. And you'll see in here that it actually shows the create or replace function command. So if I go down to the text, so it actually did a bunch of things, right? I'll go back real quick. You can see what it did. So it created a stage, put a file, so it zipped up everything, put it to a file, and then created the function, right? So all that it did for you. And otherwise, you'd have to do it yourself. Like it'd be a pain. You'd have to constantly be working with this thing with SQL wrapped around it, which is also a pain. So I think this is what this quick start shows is really a best practice way to manage the Python code and debug it and test it, but then deploy it to Snowflake in Snowpark. So you can see in this case, it's just really simple what it did, but it imported a package because later on I mentioned we were going to use SciPy. So that's in there, and then it has the zip file that it created and all of that. So just really helpful. And then when it comes to the DevOps part, we're going to use the same tool. We're going to use Snow CLI to deploy it to each environment. So it's great. So you have the same code and you have the same tools to help you deploy it. Okay, so that's the UDF. Now, what does a stored procedure look like? So let's go and look at that. And like I mentioned, these are really the pipelines themselves. The other thing I didn't mention, these are in folders. You may have noticed for the observing folks out there. I've got each of these essentially objects, the function and the procedure, in a folder. So one thing we're doing you're going to see us across the board with the Snow CLI tools, you often need metadata to make all this stuff work, right? Whether it's a Streamlit app or a Snow Services container. And so there'll be projects. So we're in the concept of projects. So with Snow CLI, when you create a procedure, Streamlit, whatever, it'll be a folder with some files in it. Some config files, I think we're doing it with TOML. That's the current. This is all still private preview, so it could change. But right now it's with like TOML config files. So we're defining some attributes for what we're building here. And then there's a requirements text. And I mentioned this could have other stuff as well. So the idea is it's not just a single script, it's really an application here, potentially. So that's the point, and then this is now a stored procedure. So I've got essentially just Python code again, but now I'm importing the client API. So remember the two parts, right? The server side and the client side. So now I'm importing the client side, and you can see that here. So I've got my session, which is like you do in PySpark, and then I've got, I'm importing using some functions as well. I've got a number of functions here. So this is actually really not a best practice, I think, to manage your objects. And this is one of the things that I see often with a lot of, well, I should be careful how I say this, but a lot of the like notebooks that I see for data engineering are often like this kind of big, long things where they're creating objects, and it's more like a scratch pad or something. Like it's not how you'd operationalize things. Because with databases, you want to have your objects managed independently. Because what if you have two notebooks that share the same object, right? You don't want to have you could take the code and you could move it into a shared spot, but either way, you want to have that kind of managed separately. So like things like creating tables and things in here, I wouldn't normally do, but just wanted to make this simple and easy and show that you can have SQL commands mixed with non-SQL commands. So here in this part, and thank you guys, everybody, seems like you're all doing okay. I know it's a pain. You can see here the merged bit. So same thing, right? We have the wrapping. So we're doing the alter, we're resizing the warehouse. And this is all now done with the DataFrame expression. So there's a merge command, just like there is in some of the PySpark implementations. And you can see here this line 39 and 40, we're actually running a merge command. And everything, like I said, in Snowflake, this all translates into SQL queries. So if I were to run this command, and I can run it locally, here, 06. Again, I can develop locally, so I can do app.py. And this will run and actually deploy the pipeline. Everything is done incrementally, so actually since I've already run everything, there's no new data. It's not gonna have any rows to merge. But you can see how we're building the pipeline. It's a script right now in Python that then when I run that snow command, if I do a snow procedure create, it gets deployed into Snowflake as a stored procedure. So hopefully that makes sense, kind of how that's working. And then we've got I won't go through the other one. We've got another similar one that does another merge command, but the query is more complicated. So actually you can see, we support, like I said, the API for the DataFrame is very similar. The overlap is pretty much, it's pretty much an overlap with PySpark. But you can see there we're doing aggregate functions, we're grouping and joining and calling our UDFs and all of that. So it's all mixed in there. So you can see we're doing some aggregations. We're calling, at one point here, we're actually calling our UDFs here and here. One's a SQL UDF, one's a Python UDF. We don't care. We're just going to call them, and Snowflake will deal with all the complexity. But you can see you can build out, the point is you can build out what you're used to in terms of the DataFrame API. All right, and then when it comes to tasks, if you haven't seen, we've got some awesome new observability features in Snowflake. So I can actually come in now and switch my role here. So we have it all up. If you see where the activity, this is like the account-wide. We have an account-wide task history. So you can actually start to see all the task executions across all of the different things. So when I run this earlier today, we skipped a task once and then ran through both of them. This is really cool because managing tasks, if you haven't done that in the past at scale, was a challenge before. And now it's much easier to manage. You can also drill into a particular task, look at that run history. We have that same, we saw that in the keynote today, they had for dynamic tables, they had this graph view. We have it for tasks as well, so you can start to see the relationship between your tasks and all of that business as well. So really cool features for task management. One, just like, I don't have it in the presentation, but one kind of fun thing, it was mentioned briefly with I forget the term we used, but we're working with the Snowpark API to support tasks. We're going to let you essentially manage all the objects in Snowflake through Python. And so we'll have that for every object. But with tasks, we're actually implementing the Airflow API. So you can actually define an Airflow, like what looks like an Airflow DAG, like very similar syntax, and it will actually deploy the tasks into Snowflake and manage it that way. So for folks that have used Airflow and are familiar with that, it's going to be awesome. So it lets you just manage it in a much nicer way and the dependencies and all that, but then deploy it into Snowflake. I think it's in private preview now. I'll have to follow up though. I just heard and I'm blanking at the moment, but that's gonna be really cool. So we'll be supporting that bit. And then I think we're just about 5 minutes out. So I wanted to show really briefly some of the DevOps stuff. So how many people are doing DevOps or wanting to do DevOps with all their data engineering? Yeah, it should be everybody. You didn't raise your hands. You should be ashamed of yourselves because you should be doing it. Where'd it go? Here we go. Okay. So if you've used GitHub Actions, this will be familiar, but you define in a GitHub Workflows folder your pipelines in YAML. So this is a really simple GitHub Actions pipeline. This is not best practices by far. We're not going through different stages. It's just showing how this works. But basically, it's simple. We're checking out the repository, setting up Python. And incidentally, you saw 3.9 and 3.10 are supported now in public preview. So that's huge. That's big for a lot of reasons. We configure Snow CLI. So this is using the Snow CLI tool. And then really what happens is it just runs a deploy script, which is in the repository, which just loops through and runs Snow CLI, just like I did in the demo. It just runs that. And so every time you deploy from test to QA to state to prod, it's the same code, it's the same tools, everything. So really powerful. And then you can see in in GitHub, I ran this just before the meeting. And when we actually deploy the apps, if you remember, this is basically the same output we saw at the command line, which is what you'd expect. So pretty cool. There's a lot happening with the Snow CLI tool, so it's going to be changing, but I think this approach gives you a good starting point for doing, for managing your objects and building these pipelines in Python.